Welcome back to Entraz. So in this video we're going to be talking a little bit about DMVPN and hopefully in a subsequent video probably a little into Flex as well to determine some of the differences between the two. So what we're looking at today, we have two potentially hub routers that are going to be our NHRP next hop servers. We can kind of see this as kind of a hub in the West Coast, hub in the East Coast, and then we have these remotes out here. Now there's been a lot of misconceptions, a lot of misinformation, I believe, about DMVPN and how it actually works and the various phases to it. So we're going to run through that really quick right now. So router 1, router 2 are our hubs. We're not going to talk about router 2 here, but we're going to get to that in the dual cloud scenario. So we're going to focus on 1, 3, and 4 for the time being. So let me move 2 out of the way. So I believe these have been IP'd already. Show IP interface brief. You'll see here that we have Ethernet 00, which is my emulated WAN connection. 0/1 is the emulated internal connection between the data centers, and a loop back just to see how things roll. I have the same thing over here on router 3. So you'll see they're on same networks. The 0/1 is connected to router 2, 0/0 is connected to router 1, and you'll see the difference in, of course, the IP addressing. For now, let me do a ping 1.1.1.255. And you'll see we get a response from 3 and 4. So you'll notice we do have connectivity between 1, 3, and 4 on our emulated WAN. So from here, I'm also going to show you the show run section for my router config. So we're going to be using eigrp here. One of the reasons for this is because eigrp is kind of the more difficult of the routing protocols when it comes to configuration, but a little easier when it comes to architecture, so to speak. Now, one of the things they talk a lot about with Phase 1 and Phase 2 is the ability to go spoke to spoke. One of the things about this is that eigrp is the whole Phase 2 deal. OSPF doesn't really have a Phase 2, it does it automatically because it's link state. We'll get to that a little later when we talk about why that is. So we have our eigrp. I'm not allowing the emulated WAN, so I have my access list blocking 1.1.1 and passive interface as well for that, because recursive routing can occur if you advertise the WAN over the tunnel. So show access -list 1. You'll see here that I'm denying 1 and denying the 2s, permitting any after that, so we should be good. So the first thing is kind of a phase half, kind of in my opinion. So we'll start over here on R1, our hub. We're going to create our interface tunnel 10, and we're going to give it an IP address. So I like using the 172.16.10.1 for tunnel 10, of course. We have to specify an IP NHRP, the next hop resolution protocol network ID, which will match, it'll be 10. We have to specify a tunnel source, which is Ethernet 0/0. And I like to do, and sometimes is required, a tunnel key, which that'll match as well. Considering we're doing a multi-point DMVPN style, we do have to do the tunnel mode GRE for multi-point on the hub. So once we do that, we'll see that we have DMVPN configured and pretty much ready to go on the hub side. So coming over here to router 3, we'll do kind of the same thing, interface tunnel 10. We'll give it an IP address, 172.16.10.3/24 mask. We have to do the IP NHRP map command to map the next hop server to its non-broadcast multiple access address, which is your WAN address basically. So 1.1.1.1. We have to make sure the IP NHRP network ID matches, which reminds me we also need to make sure our tunnel key matches. From here we have to specify our next hop server, 172.16.10.1. Tunnel source is going to be E0/0. And one of the reasons why I call this DMVPN Phase 1/2 is because you can do the tunnel destination command with DMVPN. So once you configure this, tunnel destination, you're up, you're basically a point-to-point interface, and you should have your DMVPN connection, which we have that here. It is state up. So do ping 172.16.10.1 and DMVPN is working between 1 and 3. Do show DMVPN, and you'll notice we have this as well. If we do show IP eigrp neighbors, you'll notice we have tunnel 10, we have our neighbor. Let's do a do show IP route eigrp, and you'll see that I don't have any routes. So we're actually not getting any routes from our neighbor right now. And we'll probably get an error pretty soon that says we lost eigrp neighborship. So let's look at our neighbors. So you'll see here in R3 that the neighbors don't work. So that was just kind of the tip of the iceberg on DMVPN base config. You can get it to work with these very simple commands. Show run interface tunnel 10, and it's really technically two commands, the tunnel mode and the network ID. Over here on the spoke, do show run interface tunnel 10, you'll notice it's really just a single command and then the network ID. However, one of the problems we're having right now is that multicast is not functioning. So under the tunnel, we also have to specify multicast. IP NHRP map multicast dynamic, because you always want it to be dynamically assigned on the hub. Well, at least in practice. Always do dynamic on the hub, and we statically map on the spoke. IP NHRP map multicast to the NBMA or the WAN address. 1.1.1.1. Hopefully I won't have any problems with my EVNG here, and it will work. Do show IP eigrp neighbors. So let's shut it down. Wait a minute. No shut. Alright. Line protocols back. Change states up. Dual neighbor change, down interface peer termination. Well, there we go. Now we have tunnel 10. Do show IP route eigrp. And you'll notice now that we have our eigrp routes delivered via the hub 172.16.10.1. So I'm just going to verify. Do show IP interface brief. We don't have 192.168 in here. That's the IP address, I believe, of the Ethernet 0/1. Do ping 192.168.0.0, and we get a reply. So now we know that DMVPN is working and eigrp is surely working. So now that we know we have DMVPN between a single spoke and the hub, let's add a second spoke to the mix. So we'll bring up router 4. Now one of the nice things about having router 3 already configured, show run interface tunnel 10, we can copy and paste this. One of the things I love about Secure CRT is the ability to paste, and you can modify. So 10.4 11111 Ethernet 0/0, that's correct. So we should be good to go. So that's done. We got our multicast in there, our network IDs, next hop server, and we have our new adjacency. Show IP route eigrp, and there you go. We have our eigrp routes. Show IP interface brief. So we don't see the loopback interface for router 3. So show IP route eigrp. Let's try it again. Okay, it does not show up here. How about router 3? Show IP route eigrp. We don't see it here either. So let's just verify. Show IP eigrp interfaces. Loopback 0. Show IP eigrp interfaces. We got loopback 0. Over here on router 1, show run interface tunnel 10. So one of the things you're going to notice here is we don't have any of the eigrp configuration on the interface. Now, this is one of the things I mentioned earlier about how eigrp was quirky. You'll notice how R3 and R4 are not getting routes to other spokes. So what we have to do here is we have to disable a little thing known as split horizon. Split horizon exists in eigrp and RIP. In this particular iOS, I don't have RIP for some reason, but we just specify eigrp1 for no split horizon. We're going to have our dual neighbor change, and hopefully it will come up. Hey, there we go. 10.0.4.0 via the hub 10.1. If we ping 10.0.4.1, you'll notice we get a response. If we do a trace route to the same, you'll notice it has to go through the hub before it can reach the spoke. Let's try it again. So right now we do not have spoke-to-spoke communication. So based on the do show run interface tunnel 10, we have multicast, no split horizon, and that's pretty much it. On the other routers, the spoke routers, it's all pretty much basic. So how can we get phase 2, so to speak, when we're talking about eigrp and spoke-to-spoke? Well, one of the things we can try, let's come over here to router 1. We can do no IP next hop self for eigrp and the autonomous system number of 1. Once this is done, we'll have the dual neighbor change all over again. The redundancies have come back up. So let's show IP route eigrp. So you'll notice here we're actually getting 10.4. So that route on the that route on router 4 is being delivered through router 4. So if we do a trace route for 10.0.4.1, you'll notice it hits the hub first. We do another trace route. Eventually you would think that 10.4 would be direct because it says 10.4. The problem is in our configuration of phase 1.5. So show run interface tunnel 10. This tunnel destination right here makes it so we have to go to the hub. Now if we mimic how it is over on the hub, we can come into our tunnel and do a no tunnel destination, and then a tunnel mode GRE multipoint. Do the same thing on router 4. No tunnel destination 1.1.1.1, tunnel mode GRE multipoint. So show IP route eigrp. It's coming back up. Show IP route eigrp. There we go. Now it still says 10.4, and this one says 10.3. So let's try this again. Trace route 10.04.1 goes through the hub like usual, and then it goes directly to the spoke. So that's one of the things about the Phase 2 when it comes to eigrp. There was only one thing I had to add to my hub router to get spoke-to-spoke communication with eigrp, and that was the no IP next hop self. However, I wouldn't ever recommend doing static tunnel destinations on a spoke to begin with, so the GRE multipoint would usually work fine unless you're using something like OSPF, and it will do spoke-to-spoke automatically, because in link state it doesn't have the next hop self, so to speak. In BGP it does, but that's a whole nother story. So yeah, that's pretty much it for DMVPN, at least the unencrypted portion. You have your IP NHRP mappings, the multicast mappings, the network ID, and the mode GRE multipoint. One of the last things, however, you might ask yourself, well, what about Phase 3? Now for Phase 3, it's only 2 additional commands. Interface tunnel 10, IP NHRP redirect. So the hub will redirect the configuration. It's basically an ICMP redirect. And then over here on the spokes, we do IP NHRP shortcut. This IP NHRP shortcut uses that redirect from the hub in order to get to the other spokes more efficiently. So IP NHRP shortcut. So there you go. That is a single hub, single cloud deployment. But if we wanted to get into the dual cloud deployments, we only have to tweak a few things. So let's look at 3 and 4. Show run interface E0/1. So that's on here. Show run section router. I already have the passive interfaces on there. So hopefully this will not give us a load of trouble. So on router 1, let's end out of here. Show run interface tunnel 10. So let's come and grab this. Come over here to router 2. And once again, that's why I love Secure CRT, is the ability to come in here and modify on the fly. So tunnel 20, router 2, 20.1, no IP next hop self, split horizon, network ID also is 20, and the tunnel key is 20. Everything else is pretty much the same, and we paste and are good to go. Alright, so we come over here to router 3. Same thing, show run interface tunnel 10. Let's copy this. Paste it in. Tunnel 20, 20.3, 20.1. You got to change this actually to 2.2.2.2 because that's the external IP address on router 2. Network ID has to change to 20. Next hop server is 20. And we're looking at Ethernet 0/1 now. And the tunnel key is also 20. So let's copy this. Paste. Router 4. Paste. Make this a .4. Everything should be good. Paste. And hopefully everything works. Hey, there you go. Look at that. We have our tunnel 20 DMVPN and our tunnel 10. You'll notice here that we have a dynamically created tunnel between router 4 and router 3. So let's come over here to router 1. Show IP route eigrp. Okay, looks good here. Router 2. Show IP route eigrp. Looks good here. 20.3, 20.4, 10.3, 10.4. So you'll notice that each hub uses its own DMVPN route to get to the various hubs or spokes. From router 3, show IP route eigrp. So you're going to see here that we actually have equal cost load balancing, well, equal cost multipathing, or ECMP, with eigrp. So we have 2 routes to the 10.04 and 2 routes to the 192.168. This is because all of these links are the same bandwidth, same delay. I haven't modified anything. If I was to come in here and emulate a WAN connection, we'd probably see that R3 over here has a quicker route to R1 than it does R2, and eigrp will use that method to determine which hub to go to. So 1.0.0.1 goes to tunnel 10, 1002 goes to tunnel 20. So there you go. We have just created phases 1/2, 1, 2, and 3 in a single and dual cloud scenario. That's one of the things I love about DMVPN. It's actually so easy to configure. I mean, this is it. You specify the next hop server's address and the WAN address. The WAN address, the next hop server's address, and put it in a subnet. I mean, it's just super easy the way it works. And because we have these various methods, we can really make it work any way we want. So yeah, that is it. We'll post some of these things online here as well as the video. I'm going to be getting into FlexVPN and a lot more into crypto, eigrp, and Ike version 2 for my next video. I didn't really do eigrp or Ike version 2 in this video because I wanted to focus on DMVPN, but when we get into the crypto, FlexVPN requires Ike version 2, and we can look at the difference in configurations between Flex Dynamic VPN and Dynamic Multipoint GRE VPN. So I'd like to thank you for watching this video, and we'll see you in the next one.